Okay, so another type of interconversion that you all might be potentially faced with at some point in your career is for temperature units of measure. Now, there are three temperature scales that you probably heard something about that are sort of common in everyday life and also in scientific circles, okay? And the three temperature scales are listed up here at the top of the whiteboard. There is Kelvin temperature scale, Celsius, and Fahrenheit. Now the third one, the Fahrenheit scale, it's commonly used here in the United States. Typically speaking, where you see this, I have think weather reports here on this whiteboard because if you hear the weather guy come on the TV, he says it might be 100 degrees tomorrow. He's talking about Fahrenheit, okay? Now, while Fahrenheit is commonly used for weather reporting in the U.S., it's not used terribly often in scientific circles. In fact, really not at all. Scientists tend to use the first two exclusively, okay? So these are the ones that we're going to use the most. We can, however, convert between Fahrenheit and these other two, okay, because they all measure temperature. So we're all measuring the same thing. We're just measuring things differently, okay? Now, Celsius and Kelvin are going to have some similarities in that the magnitude of 1 degree is actually equivalent in both of these scales. Now, they have different 0 points, which we'll talk about in a second, but the magnitude of 1 degree is the same here. The magnitude of 1 Fahrenheit degree, however, is not the same as the other two. 1 Fahrenheit degree is a smaller temperature change than the other two, and we'll see that reflected in the mathematics for temperature conversions. Now, before we get to converting temperatures, let's talk about these other two scales very quickly, because these are the ones that we're going to use a lot in this chemistry class. You'll use them all the time in your physical science classes. Kelvin temperature is an absolute temperature scale. The cool thing about Kelvin temperatures is it has a true meaningful 0 degrees. Okay, that's called absolute 0. 0 degrees Kelvin is called absolute 0. Maybe you've heard that before. Now in the lab, we've never been able to achieve temperatures of absolute 0. They can get very, 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 very close to absolute 0, but never truly achieved absolute 0. At that temperature, it would be believed that all molecular atomic motion will essentially cease or stop. So while they've gotten pretty close to absolute 0, they can't really ever truly get there. And the cool thing about it is it's really an absolute 0. It's a true 0. There's no such thing as a negative Kelvin temperature. Okay, it just doesn't exist. All right, so it's an absolute scale. Now, Celsius, 1 Celsius degree will have the same magnitude change in temperature as 1 Kelvin degree. It's just that there's different 0 points. Now, in the Kelvin system, that true 0 is our 0. That absolute 0 is our 0. But in Celsius, this whole scale is based on water, since water is such a familiar substance to us. By definition, the freezing point, the normal freezing point of water, is 0 degrees Celsius, and the normal boiling point of water is 100 degrees Celsius. So they set the 0 by the freezing point of water. The 100 degree mark in Celsius is the boiling point of water. They divide up that distance and temperature in 100 equally spaced segments, and that's a Celsius degree. So Celsius scale is based upon water. Celsius is used most commonly around the world. It's the most common temperature scale. All right, so how can we convert between these different temperature scales if we want to? This particular section of the whiteboard basically outlines formulas to allow us to do that. If we want to compute a temperature in Kelvin, if we've got a Celsius temperature, all we need to do is add 273.15. Okay? It turns out that absolute 0 is negative 273.15 Celsius degrees. So you basically just add this to convert between these two. It's actually pretty easy because 1 Celsius degree is the same magnitude as a Kelvin degree. They just have a different 0 point, which is offset here by this number, okay? Now, if you want to compute a Celsius temperature, you can. If you've got a Kelvin temperature, all you need to do is take the Kelvin temperature and subtract 275, so 273.15. Okay, now in this class, we are going to be using these two a lot, okay? So it's probably a good idea to kind of commit those to memory. These two equations might not be given on the exam. You just have to remember this number 273.15 is the offset between Celsius and Kelvin, and then I kind of think you can figure it out. Okay, it's pretty easy. It's just addition and subtraction. Now, on the other hand, on occasion we might need to convert between Fahrenheit and Celsius. These equations down at the bottom, which are a little bit more complicated, allow us to convert between Fahrenheit and Celsius. If you need to find a Fahrenheit temperature and you've got Celsius, the way to do it is to plug your Celsius temperature into this equation. You take your Celsius temperature, you multiply by 9/5 and add 32. The reason why you have to multiply by 9/5, remember earlier I said that 1 Celsius degree is not equivalent to 1 Fahrenheit degree? Turns out a Celsius degree is almost twice as big, okay? And hence this need to multiply by the 9/5 here. Now, if you want to convert to Celsius from Fahrenheit, you could do so using this equation. You plug your Fahrenheit temperature in here, say if it's 110 degrees outside today. You plug that here, subtract 32, and then multiply by 5/9, and you'll get yourself a Celsius temperature. Okay, so this is how we're going to convert between these. These second two formulas, I think these would be given on an exam if you needed to ever use it. This is between Celsius and Fahrenheit. I think this would be given on the exam. I could certainly lobby the other instructors to help include this. We're not going to be using these all that much in this class, to be honest with you. Okay, so it's sort of a how to do it type of thing. But this material, converting between Celsius and Kelvin, you all need to know how to do that. That's kind of a crucial skill for a physical scientist. Okay. All right, so let's work a sample problem here. A child has a temperature of 38.7 degrees Celsius. A normal body temperature is 98.6 degrees Fahrenheit. Does this child have a fever based upon the temperature reading data? Okay, so what do we need to do? It looks like we can probably take our Celsius temperature and convert it to Fahrenheit. I mean, I guess we could take the Fahrenheit, convert it to Celsius if we want. But let's go Celsius to Fahrenheit, okay? So we've got 38.7 degrees Celsius, and I want to convert that to Fahrenheit, right? So what does my conversion factor here tell me to do? Well, it looks like I want to go to Fahrenheit, so I'm probably going to use this one, right? So I need to take my Celsius temperature, 38.7, and multiply by 9/5, and then add 32. And if I do the math on that and do it correctly, that should yield my Fahrenheit temperature. Now, if I do that, it looks like I get 101.7 degrees Fahrenheit. And since that's higher than 98.6, the child does indeed have a temperature that's running a little bit of a fever. It turns out that normal physiological body temperature, 98.6 in Celsius, is right at 37 degrees. Okay? So oftentimes you'll see experiments for like biochemistry or in biology that are run at 37 degrees, and the reason why is that's kind of like this normal human physiological temperature, which corresponds to 98.6 in the Fahrenheit scale. Okay, so that's sort of normal human temperature in Celsius scale. All right, now let's practice converting the child's Celsius temperature into Kelvin. Okay, just for fun here. So let's go Celsius to Kelvin. So we were told Celsius temperature was 38.7 degrees Celsius, and I want to figure out what the child's temperature was in Kelvin. All right, so how do I do that? Well, it looks like my temperature in Kelvin is equal to my Celsius temperature plus this offset of 273.15. So I need to write my Celsius temperature, 38.7, and just add my 273.15. Just like that. So it's a pretty easy computation. It's just an addition. And if I add the two together, I get 311.8. 311.8 Kelvin is the temperature of this child running the slight fever.